So in this video, I'll be focusing on solving a few problems from the first part, sequence, series, and sigma notation. So I'll solve a few examples and a few exercises from exercise 1A, right? So yeah, so let's get into some problems. I won't exactly tell you which problems are there from the book I'm doing, as the book which you use might vary from the one I'm using. So I'll just state some questions and I'll try to solve with them. And I suggest you, after the question, you take a 5-minute pause and try to solve them on your own and figure it out, as that helps you a lot, right? So yeah, without any further ado, let's get started. First question is, I'm given summation of, let's take a variable r is equal to 1 to 10, and from r squared to r cube minus 1 by 2r. So I have to figure this out. Let's say 2r plus 1. Yeah. So this looks a bit complicated and it is really a bit messed up, but yeah, but this is not very difficult to be honest. So as you know, we take to solve this is a thing, but the summation of this value, and we just put the values of r. So first we have r is equal to 1, so it's 1 squared and 1 cube minus 1 by price of 1 plus 1. Then we add the thing, then we have r2, sorry, let's get to the part 2, so it's 2 squared times 2 cube negative 1 by 2 times 2 plus 1. This continues, right, for every variable, and since the last thing is 10, we have 10 squared times 10 cube negative 1 by twice of 10 plus 1. And yeah, this comes out to be 0, so the entire thing becomes 0, plus this 2 squared is 4, 2 cube is 8, negative 1 is 7, 2 times 2 plus 1 is 3, and then we have 10 squared is 100, then 9,999, and that's 2 times 11. Yeah, so I won't go for the details of this, as this is just simple arithmetic now, just here to figure it out. But yeah, this is how the general thing works of summation, right? Now let's try to do this thing in reverse. So let's take a sequence of numbers. So let's say we have summation of, let's say, no, sorry, we'll take a series of numbers. So let's say 3, 11, okay, 1, 3, add it to 11, add it to 19, add it to 27, add it to 25, right? And now we are given the task of writing this down as summation of two numbers. Right, so before we start on, let's see how these numbers are really formed, right? So yeah, and take a 5-second pause, think of it. Yeah, let's go do it now. So the first number is 3, the second number is 11, right? So here we just add on 8, the difference is 8, 90, next number, the difference is 8. So it becomes quite evident that the difference between the consecutive numbers is 8, right? 27, the difference is still 8. So it's 3 plus 8 times 1, 3 times 8, sorry, the plus sign isn't too good, 3 plus 8 times 2, and 3 plus 8 times 3. So this is how the pattern goes down, right? And this can be written as 3 times 8 times 0. So yeah, this is how the thing goes down, and this is pretty easy to figure it out, right? And this is the sorry, just clicked on the wrong link. The computer's response system isn't that good. I'm very sorry because of that. This is the first term, this is the second term, this is the third term. So there's another pattern which you can see. It's first term, the factor is 0. The second term, it's 1. The third term, it's 2, right? And since this is the third, this is the fourth. And so I can write this as summation of 3 plus 8 times of r, and r is from 1. And since it starts from, I will take r minus 1. So this really starts from 0. and this from 0 is 1, 2, 3, 4, 5 times to 5, right? So last term will be 3 plus 8 times 5 minus 1 plus 3 plus 8 times 4, 8 is 24, wait a minute, yeah, 8 is 23, 8, sorry, 8 4 is 32, and 25, and 35 is our last term over here. This should be our answer. Yeah, you can write this in many forms. I'm not saying this is the only correct answer, it's one of them. You can write it in many forms. Like in the book I have, perhaps they write it as summation of r equals 1 to 5, 8r minus 5. And that's correct too, right? So both of these are the same thing, right? And it's really up to you to figure out which one do you prefer. And yeah, so let's go to another problem. So that question. And yeah, let's go down to the fractions. So let's say I have a fraction which is in form of a series, and it continues like this. So it's 1 by 4, comma 4 by 7, comma 7 by 10, comma 10 by 13. So my task is to write the next three terms as my first job to do, and secondly I have to do find the general term. So take a minute or two, pause this video and see what you can come up with, right? Yeah, so this pattern is quite evident. Like if you see the numerator, it's 1, 4, 7, 10. So it's increment by 3, right? And denominator is same, 4, 7, 10, 13. As increment by 3 again, sorry, I wrote a 4. So it's nothing but an increment of 3, right? And now we have to write it as a general form. So first, before writing as a general form, let's write the first three terms. So after 10 by 3, I add 3, so that's 13, 16, then 13 plus 3 is 16, 16 plus 19 is 19, and 19 plus 3 is 22. So these are the next three terms. Simple enough, right? And now we have to find a general term. So if you see between the first and the last term, the difference is generally 3. So the general term will be n, because here it's 13 plus 3, 16 plus 3, 1. Here it's 1 plus 3, it's 4 plus 3, 7 plus 3, 10 plus 3, right? I should probably remove them. It looks a bit messy as of now. Yeah. So if the numerator, the nth term is n, the numerator must be n plus 3. And that's it. We've solved this problem. And now we'll go to some other problem. So yeah. And now we have to write a general term of the sequence. So the sequence stands out. I think we might have worked out with this last time, but still it's a good practice to do it again. So yeah, take a minute, pause the video, look into it, and try to come up with something. So yeah, I guess you took a minute and think you have come up with something. This does not seem too convincing, right? Because the differences are 3, this 5, this 7. It forms a pattern, right? This might be 9. This is a pattern of odd numbers. But how do we show that? That's the question. But there might be another thing which you might have missed, because it seems very intimidating to go for the difference of consecutive odd numbers, right? And this is what I did the first time, but it's another pattern, and that's quite easier compared to this. And that's just, so what's 0? It's 1 squared, negative 1. 3 is 2 squared, negative 1. Then it's 3 squared, negative 1. 4 squared, negative 1. And compared to the previous patterns, this is much more simpler. And if you're asked to write the general term of this, so yeah, you have to find the general nth term of the sequence. We just write it as n squared negative 1. And that's the answer. It's quite simple, right? It's also while doing the problems, strive for simplicity, as it reduces the problems and makes life easier for you. So now let's do expansion. Let's let we have summation of x equals to 1, x to the power x, infinity. So this side is infinity. So here in this context, it means the sequence never ends, right? So it's 1, 2, 3, it keeps on going. And we just expand this, and this is pretty simple, right? So we take the values one by one. So 1 power 1 plus 2 squared plus 3 cubed plus 4 to the power 4 plus 5 to the power 5. And we keep on taking this. This keeps on going to infinity. So yeah, it's not that tough to be honest. And now the last problem which I'll be doing is quite interesting, and I would tell you to take a minute off and think about it, as even I was stuck in this problem for quite some time when I initially tried to do it. So yeah, I have a sum 0 plus a third plus a half plus 3/5 plus 2/3 plus 5/7. And this goes on. So take a minute or two and think about this problem. Think, how is this working? You can think of the numerators and denominators. What's the pattern? Try multiplying numbers, adding numbers, or subtracting numbers, and try to come up with a pattern that suits our problem. Just take a minute or two. And this is quite interesting, right? And also remember, this is an infinite series. And yeah, I guess or I hope that you should have come by something, or even if you have not, no worries, because even I wasn't able to do this problem in the first try. It took me quite some long time to get a hold of what was actually happening in this problem. So yeah, let's see. So in this problem, before I begin, I'll try to multiply the terms by a factor of 2. So I'll write the term as below. So what is 0? It's nothing but 0 by 1. Then 1/3, right? Then half, then 3/5. This keeps on going. Let's say I multiply the terms by 2, right? So 0 by 2. Let's leave this 1/3. Let's write this as 2 by 4. Let's leave this. So I'm leaving numbers in an alternative pattern, and I'm multiplying both in the numerator and the denominator by 2 in an alternative manner. So next number was this, right? That's 4 by 6, then really 5 by 7. This keeps on going. And then comes the fun part. So in 0 and 2, we can write this as 1 negative 1 and 1 plus 1. This can be written as 2 negative 1, 2 plus 1, right? The next one can be written as 3 negative 1 and 3 plus 1. And I think you should be getting a hold of what's happening. So it's that I take the numbers 1, 2, and 3, the natural numbers, and I just keep on subtracting 1 for the numerator and adding 1. The next one is definitely 4 negative 1, 4 plus 1. It's 4 negative 1 is 3 plus 1 is 5. Next one is 5 negative 1 is 4 and 5 plus 1. Next one is 6 negative 1 and 6 plus 1. And this keeps on continuing. So if I'm asked to write this in form of with the help of in form of summation sign, I just write summation of r equal to 1 to infinity r. So this looks like a field. Let's write r minus 1, r plus 1. And that's the answer. Yeah, sometimes this can be a bit tricky because you have to go around multiply numbers. Like here we first multiply 2 alternatively, and then we added and subtracted 1 and created a pattern. It's all about creating patterns and looking into them. And it's quite fun to be honest. And yeah, this is what I had. So you can look into all of the other examples and questions. This is everything I had for this class. I hope you enjoyed it. Keep practicing, and if you have any questions, you can definitely write in the comments. And yeah, that's it. Thank you for staying patient and watching the video.